For days, California has been baking under one of its most intense heat waves of the year. Now it's finally breaking. That's the relief everyone's been waiting for. It's not the part of this story that actually matters most. Because as the thermometers finally start dropping, a different set of maps meteorologists watch just as closely is doing something far more alarming. Not the standard heat scale that runs from yellow to orange to red, a separate tracking tool built specifically to show when temperatures cross into territory beyond anything ever recorded at a given location, is lighting up in its darkest, most extreme category, black, the color reserved for readings that don't just feel hot. They rewrite the historical record entirely. So what's actually ending across California right now? What does it mean when a map has to reach past red into an entirely new color to describe what's happening? And why does the heat breaking not actually mean the danger is over? A state built on extremes split down the middle. To understand this story, you first need to understand something genuinely strange about how heat behaves across California, because it isn't uniform in the way most people assume. During the stretch of heat, San Francisco itself barely broke a sweat, holding in the 60s and 70s, while cities barely 20 to 30 miles inland flirted with triple digits. That kind of split isn't unusual for the Bay Area specifically. A persistent marine layer, cool. Moist air pulled in off the Pacific can keep the immediate coastline dramatically cooler than areas just far enough inland to lose that ocean influence entirely. On the most extreme days this summer, meteorologists have tracked temperature gaps exceeding 25 degrees between coastal San Francisco and inland spots in Sonoma and Napa counties, sometimes the sharpest split recorded in years. A gap wide enough that a single afternoon drive from the coast to wine country can feel like crossing into an entirely different season. But that same marine layer that spares the coast doesn't extend its protection very far. Inland valleys, the Central Valley, wine country, the Santa Clara Valley, and the deserts further south and east don't get that buffer. When a heat dome settles over California, those are the places absorbing the full, unfiltered force of it day after day, with overnight lows warm enough that even nighttime brings little real recovery. That's exactly the pattern that's defined this latest heat event. Triple-digit temperatures gripped the Central Valley and interior areas for an extended stretch, with some Sacramento area locations stringing together more than a week straight above 100 degrees, a feat that's only happened a handful of times in more than 8 decades of local weather records, while cooler coastal conditions persisted just far enough away to make the divide feel almost unbelievable to anyone driving between the two zones in the same afternoon. The map that goes beyond red. Here's where this story gets genuinely different from a routine heatwave update. Most heat coverage relies on a fairly standard scale, comparing today's forecast to typical conditions for the date, usually color-coded from cool blues and greens through yellow, orange, and red as temperatures climb firth. Ordinary hot day. It starts to break down when temperatures don't just run above normal, but actually challenge or exceed the highest temperature ever recorded at a specific location on any date in the entire historical record for that station, sometimes stretching back more than a century of continuous measurement. For that specific scenario, meteorologists and data journalists use an entirely different visual category. When a forecast temperature approaches or surpasses a location's all-time record, distinct from a seasonal or daily record, that reading gets flagged in the darkest, most extreme shade available on the scale, deliberately set apart from the merely hot reds and oranges beneath it. It's a visual signal that says, unambiguously, this location has never experienced anything like what's about to happen, a category built specifically because red alone stopped being descriptive enough for what the data was actually showing. That's precisely the territory this event pushed into across parts of the state. Multiple inland communities saw forecasts and readings threatening their highest ever recorded temperatures, not just the hottest for a given date in August, but genuinely uncharted territory in station history stretching back decades, in some cases well over a century, the kind of reading that turns a routine weather segment into a genuine historical marker for the community experiencing it. Why this keeps happening in California, specifically. It's worth understanding why California in particular keeps producing this kind of extreme record-shattering heat event, because it isn't random bad luck. Of the 10 hottest summers recorded across California in the past 128 years, 8 have occurred within just the last decade. That's not a subtle statistical drift. It's a dramatic compression of the state's most extreme heat history into an extraordinarily short recent stretch. Climate researchers point to 2 compounding factors driving that trend. Rising baseline temperatures from climate change are shifting the entire distribution of possible heat events upward, meaning what used to be an extreme outlier now sits closer to the new normal. And California's specific geography, with its complex terrain, urban heat island effects, and dense inland valleys, and dependence on a marine layer whose thickness and reliability are themselves becoming less predictable sets it up to swing between wild extremes rather than settle into simple, gradual warming. That thinning marine layer is a specific detail worth sitting with. Coastal cities like San Francisco have historically relied on that reliable, cooling fog and low cloud cover to buffer against the kind of heat scorching the interior. Forecasters have noted a trend toward a thinner marine layer during major heat events in recent years, which means less of that natural cooling reaches the coast, even as inland areas bake harder than ever, widening the very split that's defined this summer's heat pattern and raising real questions among climate scientists about whether the coastal buffer California has relied on for generations can be counted on with the same reliability going forward. What actually ends and what doesn't. So the heat is genuinely breaking. A cool down moving through the region is dropping inland temperatures by 10 to 20 degrees in some areas, with the marine layer reasserting itself along the coast and pushing cooler, foggier conditions back into San Francisco and its immediate surroundings. For millions of Californians who spent days indoors avoiding dangerous outdoor conditions, that's real, meaningful relief, and it's worth acknowledging as genuinely good news rather than treating every cool down as simply the calm before the next alarm. But a heat wave this intense doesn't simply end without leaving something behind, and that's exactly where the story shifts from thermometers to landscape. Weeks of extreme, record-challenging heat dry out vegetation dramatically, stripping moisture out of grass, brush, and timber across enormous stretches of terrain. Fire officials have specifically flagged the Sierra Nevada foothills in Southern California's coastal mountain ranges as facing the most serious fire risk connected to this exact heat event. Precisely the kind of terrain where dried fuel, steep slopes, and wind can combine into fast-moving, difficult-to-contain wildfires. As the heat dome that baked the interior finally breaks down, it's often accompanied by shifting wind patterns, exactly the kind of transition that can turn already dry vegetation into active fire danger even as the temperature itself starts falling. The grid feels it too. There's a second consequence worth understanding because it's a direct result of exactly how this heat behaves, rather than a separate story entirely. Extended stretches of extreme inland heat push electricity demand to its highest points of the year, as millions of households and businesses run air conditioning at capacity simultaneously across the hottest hours of the afternoon and evening. California's grid operators have issued conservation requests and, during past events of similar intensity, emergency alerts warning of potential rolling blackouts if demand outpaces available supply. That strain tends to peak in exactly the window when the heat is at its most dangerous, meaning the risk of losing power, and with it air conditioning, arrives precisely when people need it most to stay safe, turning a weather emergency into an infrastructure emergency within the span of a single overloaded evening. Who actually bears the worst of this? It's worth being direct about who faces the greatest danger during events like this, because the risk isn't distributed evenly across the population, and it doesn't map cleanly onto which areas actually get hottest in absolute terms. San Francisco itself presents a specific, often overlooked vulnerability precisely because its climate is normally so mild. City supervisors have raised concerns directly about the Bay Area's built environment. Older buildings, without air conditioning, limited cooling infrastructure, and a population simply less acclimated to genuine heat than residents of the Central Valley or Desert Southwest, where extreme heat is a routine part of summer life. During a Labor Day heat event in 2017, San Francisco hit a record 106 degrees, an event that led to multiple heat-related deaths and hundreds of hospitalizations, specifically, because the city and its residents were so poorly equipped for heat that severe. Officials have pointed back to that event repeatedly as proof of what happens when extreme heat meets a population and infrastructure built around the assumption that it simply won't happen, and one city supervisor summed up the current gap bluntly during a recent hearing. The city has the mapping and data, are most exposed, but not yet the funding to actually close that gap before the next event arrives. Elderly residents, people without reliable access to air conditioning, and outdoor workers carry the highest risk during any extreme heat event. And that risk compounds specifically in areas like San Francisco, where the infrastructure and public expectation of extreme heat both lag behind what inland California has had to adapt to for generations. A 95-degree day in Fresno, where air conditioning penetration is high and residents have decades of practiced heat routines, carries meaningfully less risk per capita than a single 90-degree day in a San Francisco neighborhood full of century-old buildings that were never designed to shed heat in the first place. A pattern that keeps repeating. This summer, if this transition, extreme heat easing directly into fire danger, sounds familiar, it should. This is now a recurring shape to this entire summer's weather across the American West. A heat dome builds, pushes temperatures into record or near record territory, and then, as it finally breaks down, hands off directly into elevated fire risk across the same terrain it just spent days drying out. This series has already tracked that exact handoff play out over the southeast, where heat dome breaking gave way to severe storms and catastrophic flash flooding, and again over the southwest, where retreating heat handed conditions directly to extremely critical fire weather across the Great Basin and Pacific Northwest. California's version of that same handoff simply wears its own distinct face, colored not in the red of a severe thunderstorm outlook, but in the black of a heat map that ran out of room on its normal scale. That handoff connects to the same broader atmospheric pattern this series has tracked across the country all summer, a reorganizing jet stream and a rapidly strengthening super El Nino keeping weather systems locked in. Plays for unusually long stretches before releasing that stored energy suddenly, whether as severe storms in the east or fire-fueling wind and dryness in the west. California's specific vulnerability, its sharp coastal inland divide, its thinning marine layer, and its historically compressed cluster of record-breaking recent summers, makes it one of the clearest examples anywhere in the country of exactly what that broader pattern looks like on the ground. What actually happens next. So here's what genuinely matters going forward, beyond any single day's forecast. Watch the Sierra Nevada foothills and Southern California's coastal ranges, specifically over the coming days, since that's where officials have already flagged the most serious fire risk connected directly to this heat event, right as the dome breaks down and shifting winds arrive. Watch whether the marine layers return to the coast, hold steady, or thins out again quickly, since that thinning pattern has been a recurring feature of this summer's most extreme heat events and directly determines how sharply the coastal inland divide reopens the next time a ridge builds. And watch how power grid demand responds as this cooldown takes hold, since the margin between comfortable relief and another strained blackout risk evening has repeatedly come down to how quickly inland heat actually breaks, versus how long it lingers before finally releasing its grip. The heat baking California is genuinely ending. That part of the story is real. Welcome relief for millions of people who've spent days sheltering from dangerous outdoor conditions. What isn't ending is the underlying vulnerability that produced a map dark enough to need an entirely new color in the first place. That vulnerability doesn't cool down with the temperature. It just waits, dried out and primed, for whatever comes to light the next match, and it will still be sitting there the next time a ridge of high pressure decides to settle back in over the same stretch of ground.